Okay, it's me again, Drankata, and I'm coming up with more mathematical problems to deal with. So, if you want to get more details in integration, I would like you to subscribe to my channel so that you always uh, keep updated to any video that I will post on YouTube. Okay, let's start. This is a very interesting integration question. Find the integral of cos inverse of sin SDS. It's a very complicated. You have to go through a lot of thinking before you can solve. So let's solve it. Let's go. Let's move on. Our I is equal to the integral of cos inverse of sin SDS. Research integration question. You cannot um, do straightforward integration. You have to manipulate your function to get a function that you can forwardly integrate. So let's try to manipulate our function. Let's change our sin x here to something. So let's say that our a is equal to what? Sine of what? X. So putting a into our equation 1. So our I is going to be equal to the integral of cos inverse of a dx. Okay. Research integration. It's very easy to integrate. But from here, we want to integrate with respect to a, not with respect to dx. So we have to change our discrete addition to a different discrete addition of the a. So before you can change it, we have to change our ds to dA, and we will get that by differentiating our equation 2. So a is equal to sine x. So differentiating this, we are going to get the a, the x is equal to sine x, the sine s dx, which is equal to cos of x. So our the a is going to our the a over cos of x is going to be equal to the x. So in place of our dx here, we are going to put there our dA over cos x. So I is now going to be equal to the integral of cos inverse of a dA over cos of x. So our equation is now I is equal to the integral of cos inverse of a over cos of s dA. Now we are integrating with the a, not with the s, but we have our x as a variable in this function. So what should we do? We have to change our x to a so that we can integrate with respect to the a. Okay, let's move on. So I'll go stuck somewhere here, because how can you change this from the x cos of x and put there a? Okay, let's go back to our equation 2. We know that our a is equal to sine of x, and our cos of x is equal to root of 1 minus sine squared x. And from here we know that a is equal to sine x, so here we can put the a in place of the sine x. So our cos of x is now equal to root of 1 minus a squared. So we are now going to put this into this equation. Okay, so our I is now going to be equal to the integral of cos inverse of a over root of 1 minus a squared dA. Okay, let's continue. So our I is now equal to the integral of cos inverse of a dot 1 over root of 1 minus a squared dA. So now we have gotten two separate interesting equations that we can do with. Okay, so we have a product of two functions, our 1 over root of 1 minus a squared and cos inverse of a. And to solve such integration question, we have to use integration by part, because it's the product of two functions. And when two functions are multiplying, one of the function is being differentiated, and the one is the same function. And to use integration by parts, our I is now going to be equal to u of a dot v of a minus the integral of v of a dot u prime of a dA. So we must assume that one of the functions have been differentiated and one is not differentiated. So let's come back here. So here I will choose that my differentiated function, my undifferentiated function is cos inverse of a. So our u of a is going to be equal to cos inverse of a. So if I differentiate it to satisfy the equation, it is going to become u prime of a is equal to 1 over root of 1 minus a squared minus this is the differentiation of cos inverse of a. Okay, I hope that is clear. I can continue. Okay, and v prime, my differentiated part is now 1 over root of 1 minus a squared, and my v is now, if I integrate this, I'm going to get sine inverse of a. Okay, so coming back to my equation. Okay, so my I, putting the UA, which is cos inverse of a, so cos inverse of a dot, and my VA is sine inverse of a, so sine inverse of a minus the integral of sine inverse of a. My differentiated of cos inverse of a was dot 1 over, there's negative here, sorry, over 1 minus a squared. So my I is now going to be equal to cos inverse of a sine inverse of a minus the integral of, so I can bring my negative out and now going to become plus my sine inverse of a dot 1 over root of 1 minus a squared dA. Okay, this seems like the same as this one, but it is the cos inverse and the a inverse, which are sine inverse, which have had changed. So from here I'll say that I'll make a1 to be equal to the integral of sine inverse of a dot 1 over root of 1 minus a squared dA. So my I can now be represented as cos inverse of a sine inverse of a plus I1. I hope you guys are following. I'm just going through I'm evaluating my integration to get my I. So please follow, don't get lost anywhere. Okay, and if you got lost or did not understand anything that I did here, you can comment it me on YouTube. Okay, so let's now find our I1. My I1 is equal to the integral of sine inverse of a dot 1 over root of 1 minus a squared dA. So to integrate this one, I have to use integration by part, the same thing. And here too, because I chose my cos inverse. Here I chose my cos inverse. I integrated my cos inverse. I differentiated my cos inverse. Here too, I have to differentiate my sine inverse. Okay, so I'll choose that my u of a is equal to sine inverse of a, and my u prime of a is going to become 1 over root of 1 minus a squared. That's when you differentiate sine a. And my v prime of a is now 1 over root of 1 minus a squared. So my v of a is now equal to, if I integrate this, I'm going to get sine inverse of a. That's just the reverse. If I differentiate this, I'm going to get 1 over root. So if I integrate this, I'm going to get that. So that's it. So my I1 is now going to become, so from using this equation, this same equation, u of a dot v of a minus the integral of u of a u prime of a dA. So the same equation. So I'm going to just put the insert this from this derived into the equation. So my u of a is now sine inverse of a. V of a is also sine inverse of a minus the integral of, so my v of a is sine inverse of a dot, and my u prime of a is 1 over root of 1 minus a squared dA. Okay, let's continue. So my I1 is now equal to sine inverse of a all squared minus the integral of sine inverse of a dot 1 over root of 1 minus a squared dA. And this, guys, are you getting this? This is the same as our I1, which is the integral of sine inverse of a dot 1 over 1 minus a squared. So you have gotten the same thing here. So from here I can put, this is equal to I1, so I can put my I1 also here. So it's going to become I1 is equal to sine inverse of a squared minus what? I1. So I'll move my I1 here. So if I move it here, I'm going to get 2I1 is equal to sine inverse of a all squared. So if I want my I1 is now equal to my sine inverse of a all squared over what? 2. Okay, so we are coming to an end of this entire problem. Okay, let's continue. So I'm going to put this back into my equation, here. So my I is going to become, I is now equal to cos inverse of a sine inverse of a plus my sine inverse of a all squared over 2. So my is equal to sine inverse of a bracket cos inverse of a plus sine inverse of a over 2 plus c. So this is the integral of cos inverse of sine s dx. So if you are asked to find the integration of cos inverse of sine x, you have to go through all this process to arrive to this. And that's why I said that the question is easy but complicated one. You have to do a lot of thinking before you can solve. And if you like this video, I would like you to subscribe so that you can get all the details of my video. Thanks. I'll be coming up with more problems. Bye.